Hello guys, welcome to my video in which I'll show you how to make a device I've made, the TEMPGUN. The word TEMPGUN is the acronym for the words taser, electro, magnetic, pulses, generator, with a UN added to make it sound like a gun. It incorporates a high voltage module, which is one of the most vital components of the device. From the one side, the TEMPGUN has a spark gap, which can be used to supply high voltage, and on the other side, there is a coil. To understand the device you have to take a look at the blueprints, especially at the 3.4.6.2 version blueprints, which is the current version of the device after some post-video modifications. Things we might need: tools, saw, optional, soldering iron, with soldering wire, blowtorch, paper cutter, hammer, pliers, mask, gas mask would be preferable, glasses, airtight glasses would be preferable, fan, optional, screwdriver, cordless drill, with small drill bits, glue gun, materials, high voltage step-up booster module, from 3.7 to 7.4 volts to almost 50 to 100 kilovolts, length almost 9 centimeters, you can probably find it if you search on eBay. High voltage step-up module voltage booster 1000 kV, tube, length about 0.5 meters, diameter about 7 centimeters, plexiglass, length about 0.5 meters, width about 0.5 meters, thickness about 3 millimeters, 6 screw terminals, 4 crocodile clips, 6 nails, magnet wire, nearly 4 meters for a 25 turns coil. More turns are probably not needed. No matter what I did, if its insulation spoils from high voltage, you might as well prefer insulated plastic garden wire. That's what I used. It's also cheaper, €2 for 50 meters. 2 batteries 4.5 volts which will be connected in series. The type of battery I used was 3R12, 2 hinges, 1 on-off switch and 1 push-button switch, double cable, duct tape, permanent marker. In total they cost about €25. Now, to begin with, we have to take our tube. Some sanding on the edges will make it a bit better for later, but, since sanding didn't work for me, I used a soldering iron to melt it. Note that this is very dangerous, so don't do it, as the fumes might cause several health problems, especially if you do it without protection. The same applies for using a hot paper cutter to melt plastic too. In fact, I used some welding goggles, a mask and a big fan, as extra protection. Later on, the caps that will close some of the open parts of the device shall be cut. Remember, their diameter should be the same of the pipes. I used the tube to draw 6 of them on a plexiglass and then I tried cutting them with a saw, a soldering iron and a hot paper cutter. The saw was very slow, so I didn't prefer it. The soldering iron was I think the fastest, but it created too many fumes. The paper cutter was a bit slower than the iron, but it produced less fumes, so I used the soldering iron and the paper cutter. By the way, notice that my paper cutter had a plastic casing. If it was metallic, I might have burnt my hands. Now that we've cut the caps, we are going to make the first part. In the first part, I've used some garden wire with a plastic protection, since my magnet wire had short circuit issues. This part works almost as an AC transformer, due to the pulse of DC current that runs through the coil. Our coil can be called as the primary and the targeted device as the secondary, for example a PCB. The PCB acts almost as an one-turn coil, so, the less the turns of our coil, the higher the voltage induced in the PCB. But if our coils has very few turns, then its area of impact might be near zero. But, if I remember well, I didn't those when I made the coil. So, my coil has nearly 100 turns. I used all 50 meters of the wire, and its area of impact is almost 2 centimeters. To increase its area of impact, we would probably need input current of higher amperage, or maybe some capacitors could help as well, but they would probably make the current less pulsive, thus probably creating problems in the operation of the device. To make the first part, we have to cut a part of the tube. The cut part should be a little bigger than the height of the coil. I used a paper cutter to cut it. After we've hot glued a cap on one side and we've placed the coil, we are going to drill 2 small holes on the other cap for the coil terminals to pass through. For the second part, we have first to estimate the space that our components will take up in order to cut the tube right. This part could also be called the power center and controller, because there's where the high voltage module is along with the batteries and the switches. The hardest part is probably here, when we make the circuit connections. After we've cut the tube, we are also going to cut it horizontally and then connect them with a hinge, to help ourselves in putting in the components. Here's the circuit to know how to make the connections. One guy also told me that if the two switches are closed simultaneously, attention, then the device short circuits, but I didn't know that and I wanted to use a push-button switch and a continuous switch. You've probably noticed that I didn't use any LED. That's because it was getting overvoltaged and I had thought about removing it. The switches are going to be placed on the upper part, while the batteries and the module on the bottom part. For extra stability I used some zip ties to hold the batteries and the module, and I used some duct tape to insulate the connections. Moreover, since the batteries didn't fit inside, I cut a small door for them. Furthermore, we have to cut the caps in the half too and drill a small hole to each of them for allowing external terminals coming in. We might as well do some tests to check if our circuit works. For the third part we will to use almost what's left from the tube. It has to be a bit long piece. From one side we glue a cap and make 2 small to medium size holes. Because the wire is a bit thicker, I used the soldering iron to make those bigger holes. The wire has to have kinda good insulation, since kilovolts will probably run through it. The longer the wire, the longer the distance it can be ejected. My nearly 10 meters wire can be ejected almost 6 meters. Knowing how to fold it back is important. It should be folded as a compressed spring or a compressed wave or circles put in parallel and then compressed. If the folding method is the common one with a circle over a circle and so on, the wire won't be able to move freely and it won't go far. Especially if you have a long wire like this and fold it with the common method, you will eject a big bulk of wire that will move nearly 20 centimeters. Here it is a failed thing I tried. I tried to add some small doors in front of the spark gap, but the hinge got stuck because of the glue and generally it wasn't very practical, so I didn't make it. Somehow the wire has to be held to be ejected. I came up with making a handle that will be able to throw the wires that will be placed in a plastic piece and connected to some nails. The dimension of the handle and the plastic pieces are shown here. Also, the handle has to be able to stay on the tube. To do that, I cut a small part of the tube, put 2 nails on the front and 2 nails some centimeters back, where in the middle the handle will be placed. Moreover, I clipped in half those 4 nails, because they were unnecessarily big. Again, this is the failed thing I tried with the small doors in front of the spark gap. Notice that the double wire should be split in the end for some centimeters to allow the handle to throw the spark gap. Do you remember those holes we had made? Now they are going to be useful. If you want, you can also go back and check the circuit. I've implemented some crocodile clip connectors and some screw terminals connectors to make the connections. Notice that all the terminals go to the second part, because that's where the connections happen. Since it's hard for me to explain the connections, you can see the circuit, the blueprints, and watch me showing the connections. After we've made the connections, we can use duct tape to hold the parts in place. Probably it's not a very sturdy solution, and I had thought about using some things with some small screws, but the screws might cause problems to the insides of the device. One thing I've probably forgot to film is the making of the grip for the device. I have some pictures of it and a sheet with the dimensions of it, which you could use to hold the pieces. I've hot glued them and then glued the grip to the device. To add extra stability and sturdiness, I used some duct tape. Yay, it's finally built. It took me about 4 days to make it and one more after 1 week to do some modifications. The dimensions of my device are almost 50 cm by 8 cm by 8 cm. I will also show you some tests of the first part. Big thanks to HackTuber, previously known as American Hacker, Keystone Science, Ludic Science, FPS Weapons, Bigclivedotcom, DiodeGoneWild, Electroboom, Azagro and Xemo. So, here is the device after almost 1 year.